During these years, data has drastically increased along with the development of electrical industry and information technology. Billions of people can get access to the internet today and daily create petabytes amount of data in terms of self-made content, random messages, system logs and etc. Holding subscribers' information, who constantly generate billions of transactions every single day. Telcos possess valuable knowledge resources which can potentially help them gain customers' insight. It seems to be a powerful weapon which can effectively enhance telcos in the fight with VTsoft services and other telcos. In order to utilize big data and achieve business advantages, telcos must have the capability to cope with the big data challenges, which includes: firstly, is the large volume of data amount stored and aggregated. Secondly is the requirement in quick data processing. Last but not least, is the multifarious format of data. vRTAP, Viettel Real-time Analytics Platform, is built to solve all of those three challenges. vRTAP Viettel Real-time Analytics Platform is a big data framework which unites both data batch processing solution and data stream processing solution. It provides an advanced approach in synthesizing and collecting data from multiple sources, accelerates the process of analyzing data, and enables enterprises to utilize automatic data mining mechanism in discovering new customer insight knowledge. The chart shows the overview architecture of vRTAP system, which includes 4 subsystems: data warehouse, real-time analytical processing, campaign online and management information. Data, which includes logs and real-time messages, are constantly fed from resource systems like OLTP systems, application layer, and core layer into vRTAP through log collector and tapping system, as you can see in the figure. Data warehouse subsystem is a center storage system that can be used for data queries from other subsystems. In vRTAP, data warehouse subsystem is organized into 2 main layers: foundation data layer and data analysis layer. The foundation data layer contains large amount of data which expands with a very high speed and must satisfy the requirement of being highly available and data loss resilient. Therefore, we decided to build this layer upon the base of RTAP distributed file system. The data analytics layer, on the other hand, is less volatile and contains smaller amount of data. This layer is used to directly provide information to end users and other IT system. Hence, it is organized in the form of star schema in RDB, MS. The second subsystem mentioned here is RTAP, Real-Time Analytical Processing. In this diagram, mining ETL periodically collects, standardizes data from source systems to feed into mining source with the most up-to-date data. In the meantime, the trading process is executed automatically in order to update the mining model based on new data. The new model will then be compared with the old one by means of evaluating process, and the most accurate model will finally be selected as the result of RTAP subsystem. The third subsystem, campaign online system, allows users to apply promotion campaigns and real-time analytics on their customers rapidly based on customers' behaviors and habits. In this diagram, log consumer or message consumer collects data from different sources in real time and feed into streaming process module via in-memory queue. Streaming process module will then apply mining model on received data to predict appropriate business rules that should be implemented. This suggestion will then be automatically acted by action process module. Finally, transfer agent moves data from in-memory storage to historical storage. The last one, management information system, provides scheduled reports which support for monitoring and management. This workflow runs through following steps. Data from different source systems is transformed and loaded into foundation layer by means of ETL workflow, which was designed by a ETL designer and monitored by a ETL master and ETL slaves. Then, data are processed by a ETL slaves to transform it into more comprehensive knowledge and store it in analytic layer. Data analytics experts can use by server or other presentation tools to visualize knowledge stored in analytic warehouse and create intuitive reports. vRTAP has been widely applied into Viettel daily network and business management, as well as into supporting Viettel business strategies. Its main features for end users fall into two main categories: creating business strategies based on mining customers' behavior, needs and demands, building business reports from multiple data resources to enhance management capability. Currently, we've already successfully integrated on vRTAP platform with four main business strategies, which are: determining customer churning. This means Viettel can predict which individual customer is prone to leaving the service. Classifying and naming customers. Viettel can evaluate customers based on their consuming behavior. And then, we can group subscribers who have identical consuming characteristics into groups, like people who love to use data, people who prefer SMS, and etc. Determining customers' habit and hobbies by analyzing their URL while they reusing 3G data. To predict what are customers' favorite items or products and target customers with appropriate advertisement or marketing campaigns. Determine subscribers who has strong interaction to other subscribers by using social network analysis. A no less important application of vRTAP is the capability of collecting data from different resources, which includes both online and offline sources, and centralizing data into warehouse. After that, by means of reporting system, perceptive and customizable reports can be created to offer Viettel managers with holistic observations of all current network operations and business activities from multi-dimensions point of view. A sample scenario of this application includes three main steps: design ETL workflow, schedule and execute ETL jobs, extract and summarize reports. In the first step, we design the collecting, aggregating, and transforming data procedures in the form of workflow model, which includes different task groups. These task groups are arranged in logical order to achieve certain purposes. For example, collecting subscribers' SMS consumption data from call detail records. Breaking down these task groups, we can see flow of detailed tasks such as get or put file from FTP, unzip files, execute SQL queries, and etc. In order to schedule for these workflow, we move to the second step, which is schedule and execute ETL jobs. By using the monitoring interface, operation engineer can set up execution time for every single workflow. Status of workflows can also be monitored by this interface. Lastly, data aggregated from the previous steps will be used as input resource to build up unified reports dynamically according to end users' requirements. On the screen is an example of statistical report which represents accumulated increment of subscriber number by day. Data can also be represented dynamically in different views such as OLAP, dashboard, and ad hoc. As you can see, our system can represent data in multifarious demonstrations under OLAP format, such as stack chart, column chart, area chart, multiple bar chart, line chart, heat grid chart, pie chart. As a powerful big data platform, the RTAP has been deploying in 4 markets of Viettel, which includes Vietnam, East Timor, Cameroon, Peru. By the end of 2016, we suppose to expand this platform in all of Viettel foreign markets with more advanced functionalities. We hope this platform can bring new wind of change to Viettel as well as increase our capability in competition with other CSPs in the market. Thank you very much for your listening.